another video, this time due to an email request that I've received asking me to explain about 2 to 4 line decoders. So this is what this video is going to be about, and aside from that I'm also going to explain about decoders and encoders in general. But let's first start by having a look at what we have on the breadboard right now. So the breadboard has 2 separate circuits on it. Here, this side has a 2 to 4 line decoder. It's an HC139, a dual one, where I'm only using a single line decoder. And on this side of the breadboard, we have a 3 to 8 line decoder right here, and we have an 8 to 3 line encoder. And I'm going to use this example to make everything more clearer. But let's start with the 2 to 4 line decoder. So what a line decoder basically does, it decodes a signal that comes from 2 separate lines into a signal that will go to either one of 4 lines on the output. That's pretty much the functionality. So we can see that, for example, once here we have our 2 input lines, and if both input lines are low, then we are talking with device number 1, and if one line is high and the second line is low, then we are talking to device number 2, and if the first line is low and the second line is high, then we are talking to device number 3, and if both are high, then we are talking to device number 4. This is the functionality of these chips. Now, just to explain what they are used for, well, they are pretty old, but the technology is still used today. These are used basically for multiplexing. What multiplexing means in a nutshell is that we are communicating with more devices than actual lines that we have. So we take data and we send data across a single line or 2 lines, and that data gets distributed at the end to go to more devices than actual lines that we have. So at this point I'm going to leave these 2 to 4 line decoder aside, and we're going to talk about the next circuit here, which is a 3 to 8 line decoder with a 8 to 3 line encoder. And what we have here is first of all the decoder, which is an LS138, and you saw me use it in numerous examples on my previous videos. And here we have an LS148, which is our encoder, and this I also made an example on how to use it on my channel. But the only thing that connects the LS148 to the LS138 are these 3 lines right here. So that's why it's called a 3 to 8 line decoder and an 8 to 3 line encoder, because the encoder will take 8 separate lines, and based on the input that we are giving these lines, it will encode it into a certain value, which will be sent across, reach the decoder, and the decoder will decode the value that comes on these 3 bits back to either one of 8 channels. So to make this example a bit more clearer, multiplexing is something that if you want to learn about, I would suggest Googling it, and you will have plenty of information to go through. But if you think, for example, about a telephone line in these modern days needs to handle all kinds of data, not only telephone calls. So we would have telephone calls. It also needs to handle, for example, internet information, data that comes from the internet. It needs to handle cable TV or satellite TV. So we're already looking at several devices that utilize a single line to move all the data and distribute it eventually through all the devices. That's what multiplexing is in a nutshell. And again, here we have 8 inputs that are encoded into a 3-bit signal, and that signal on the other end would be decoded back to either one of 8. So just like you saw here in the example where I showed you that if this one is low and this one is high, then we are communicating with different channels. Here we are doing something else. Here we have 8 buttons. These 8 buttons, they don't represent what these 2 buttons represented just now. These 2 buttons, if we want to have an equal representation, then I would remove this entire encoding circuit and just use these 3 lines, and instead of these I would put buttons, and that would be the equivalent of what I did here. But here we have 8 buttons, and you can see right now all the buttons are on low, so we are communicating with the first channel on the other end. And if I set the first one to high, then we are communicating with the second channel. And if I set the first one and the second one to high, then we are communicating with the third channel, and so on. So all the buttons here, every time we raise one high and the following one will be a low, that's the channel that we are talking to on the other end. This happens in computer systems really fast. So you're sending data very fast, and you have 2 timers sitting on either end that synchronize the sending and the receiving, and it's a little bit more than what you see here in the circuit. But again, another example to try and make this a little bit more clearer. If we would go back here to our 2 to 4 line decoder, and we would say that at the end of each output sits a binary counter, and the end of each output is connected to the clock pin of the binary counter, and that clock pin will go one count further once it goes high. So it's once it goes low, sorry, so it's on the falling edge. It goes another count on the falling edge. So that means that all the lines are high, as you can see here, but momentarily, once we move to a different line, then we provided a low, and that means that, for example, the counter that sits on this output will go a step further, and then this counter will go a step further, and then this counter will go a step further, and again from the beginning, this counter and this one and this one and this one, and that occurs really fast. But that's the whole idea behind the encoders and decoders. The idea is that we can communicate with more devices than actual lines that are available to us. And if you would imagine that this encoder here sits in one room and this decoder here sits in a totally other room, instead of having to use 8 lines to communicate with the 8 devices or functions that sit on the other side, we only need to have 3 lines for that. So that's it. That sums up this explanation, and I hope that it was clear enough. And again, if you want to learn more about multiplexing, then just Google what is multiplexing, and you will receive plenty of information about it, about the different methods of multiplexing, using frequencies, using pulse width. But in a nutshell, this is what these encoders and decoders do. I hope you liked this explanation. I hope I was clear enough. And if you have any questions, then feel free to ask or leave a comment or send an email, and I will do my best to answer. Hope you liked this video, and I'll see you next time. Thank you for watching.